Hi guys, I hope you're enjoying your unexpected day off. Since today was supposed to be a wrap-up day anyway, there's not a lot of new examples I'll be doing with you. Today's mostly going to be an opportunity for you guys to practice. By the way, I will be checking both Day 2 and Day 3 guided reading notes next class, probably during your quiz. Yes, the quiz is still on for next class. It's going to cover all of Chapter 10, so that's going to be 2 sample procedures for proportions and 2 sample procedures for means. We're also going to be starting Chapter 11 next class, which is about inference for categorical data. But it's different from the Z procedures that we've done so far. If you're taking AP Bio or you have taken it, you'll be familiar with at least one of the chi-square procedures, except that in AP Stat, you get to use a graphing calculator. By the way, if you have a TI-83 calculator, you're going to want to get the chi-square app from me. It's a built-in function on TI-84s and higher, but not on 83s. But there is an app for that that'll make your life a lot easier when you're working on Chapter 11. So remind me next time I see you in class. So here's the agenda for this virtual class. I do suggest that you do the warm-up for practice. Give yourself 15 minutes and see how you do. If you're not able to do pretty well, you might want to go back and do some additional homework problems. You are going to be expected to be able to do 4-step procedures for your quiz. So we are going to go over 2 sample versus matched pair, just a summary, and then I'm going to take you through reading some computer output. We're going to be looking at more computer output in Chapter 11, and it's going to be a pretty big emphasis for the rest of the year. In other words, you can expect to see it on all of your tests and the AP exam. I'm also posting some extra Chapter 10 practice problems, including one for Appy. It might help you get ready for the quiz. So let's go ahead and get started. This is the warm-up that I had ready for you guys. It's based on a project that some of my students did a few years ago, and it's comparing plastic bags from Target and plastic bags from Giant. So part A is going to be to construct and interpret a 99% confidence interval for the difference in mean capacity of plastic grocery bags from Target and Giant. So you should know by now what the 4 steps are to do a confidence interval. So you should be able to do that and then go back and check your answers against your homework or against problems in the book and make sure you have everything you're supposed to have. Part B, because it's a common follow-up question, is going to be to tell me if your interval provides convincing evidence that there is a difference between the mean capacity between the 2 stores. So this is a good place to go ahead and pause the video and go ahead and try this on your own. You can find this on Blackboard. You can either print it out or do it on your own paper. It doesn't really matter. I'm probably not going to be collecting it, but it's going to be a really good way to see if you are prepared for the quiz. Hint, hint. So go ahead and pause it now, and I'll see you when you get back. So welcome back. I'm going to go ahead and summarize some of the differences. It's a short comparison between matched pair procedures and 2 sample procedures that we've been doing this chapter. Last chapter we had some practice with matched pairs. So whether you're doing a test or a confidence interval, when you're doing a matched pair study, you always start with paired data. The way that you got your data in the first place, there's a reason that 2 particular numbers are going to go together. That can happen in a couple of ways. Sometimes your subjects or experimental units are matched in pairs. So identical twin studies are a good example of this. Or if you're doing an experiment with, say, plants, you might match up 2 plants that are very similar in all the things that matter. For example, they might have the same genotype. And then from each pair, one goes to one treatment group and one goes to another treatment group. Another way this can happen is if each subject or experimental unit is given both treatments, and then they calculate the differences. Another example of that is to do a before and after kind of study. So your response variable is measured before a treatment, and then the treatment is administered, and then the response variable is measured again after the treatment, and the differences are calculated. So however the paired data started out in the first place, you end up with differences. You're going to calculate all the differences for each pair, and you're going to end up with a single list of numbers, which is why we can use 1 sample procedures for this. Usually if you're doing a test for paired data, your null hypothesis is going to be that there is no difference. So the differences are 0 basically, or the mean difference is going to be 0. And then your alternative hypothesis might be that there's a positive difference, or that there is a negative difference, or that there is a difference if you're doing a 2-sided procedure. There's also sometimes a confidence interval, so you can see not just if there is a difference, but how large the difference is or isn't, depending on the interval that you actually get. In this chapter, we've been working on two-sample procedures. And the important thing that differentiates it is that you're using two-sample procedures when you have two independent groups. So if you're doing sampling, then you're sampling a group from one population and you're sampling another group from another population. So you're sampling from two different populations, so they should be independent. Or sometimes you're doing it because you're comparing between two different treatment groups in an experiment. You'll see a lot more examples from experimental studies for this because you're comparing if there was a difference in a response variable for one group versus a different group. So once you have these two independent groups, you're going to have two lists of numbers. And again, this is the procedure we have to check the conditions for the individuals for each group, not just for all of the differences or all of the pairs. Again, the null hypothesis for this is generally that there is no difference between the means, so you're not trying to find the mean difference. You're trying to see if there is a difference between the two separate means. And your alternative hypothesis could be greater than or less than or not equal to. But again, the paired data, you're looking at the mean difference, so you have a bunch of differences and you're trying to see what the mean of those differences is. And when you're doing a two-sample procedure, you're trying to find what the difference is between the two separate means. So you have a mean for one group and a mean for another group, and you're trying to figure out what the difference is. I didn't used to have a Venn diagram on this, but a student a couple of years ago suggested that it would be a good way to have you guys summarize what you've learned about matched pair and two-sample. So if you want to go ahead and to try to make sense of it in your own head, put some characteristics that are different, especially between matched pair and two-sample procedures. It might also be a good place for you to put the different calculator commands or differences in conditions that would have to be met, just to kind of summarize and put this together in your own head. Now the example on the next page is one that we're not going to be doing right now. We'll discuss it in class at a different time. But go ahead and pause the video and fill out this Venn diagram, and then we're going to be skipping ahead a couple of pages.